right, there are 2,615 students and 50 staff at Pinnacle High School. Let's say a zombie virus broke out starting with one student and seems to triple every half hour. How many people would be infected after 3 hours? So let's write an equation for this really quick. So remember, it's y equals a times b to the x power was our equation from Friday. A is the number that you start with. So how many zombies do you start with? One student, yep. And then it says it triples. So what's that? Multiplying by what? 3, yep. So basically just 3 to the x power. So when it says how many people would be infected after 3 hours, so it says that this happens every half hour. So how many half hours is 3 hours? Mm-hmm. Okay, so now you just need to put that in for the exponent. So y equals 1 times 3 to the 6th power. So what's that equal? So everyone have a calculator. You'll need one today. Yep, so 729 people would be infected after 3 hours. About how long would it take for all of Pinnacle to be infected? So let's figure out how many total people. So let's add those up. So you get 2,665, right? So there is a way that you could solve this for x, but you guys won't learn it until Algebra 3, 4, or pre-calculus. So if you plug that in for the y, then the issue is that like getting the exponent solved for, which you guys don't know how to do. So we just need to guess and check. So we know after 3 hours it's that many people, right? So let's do 3.5 hours. So multiply that by another 3. So what's that going to be? No, so like if we did 3.5 hours, so multiply that 729 by another 3 to figure out like after another half hour goes by how many people. Oh, I see what you're saying. 7.5. Yeah. Okay, 2,187 people. Is that going to be everybody yet? No. Okay, so then multiply by another 3. Let's figure out after 4 hours. So you could either do like 3 to the 8th power now, or you could just take that and just multiply times 3, because that'll be like another like exponent going up. Okay, so that's too many, right? So we're just going to say we're not going to get it down to the minute. It just says about. So we're just going to say between 3.5 and 4 hours.
Is that how like put it on your test?
Yeah, so I probably wouldn't like ask you one that's like broad like this on it, or to be a multiple choice where it's like you would just pick the one that makes actual sense, yeah. So Friday what we did is we did basically this. So this formula where something is like doubling or tripling and so on. Today we're doing exponential growth and decay, which is basically we're using the same formula, but you're going to increase or decrease by a percentage instead of like tripling or doubling, okay? So your objective is students will be able to model exponential, bless you, growth and decay. All right, so we are going to do 3 types of problems in this unit. We're going to do exponential growth, which is where you're growing by a percent. Then we're going to hop over to compound interest, which is a type of exponential growth. It's just the formula is suited to make sense for this scenario. So compound interest is basically where, let's say that you have like an investment account, and you put a certain amount of money in there. And do we all understand how like interest rates work? So there's a percent, and like every year, that percentage of your money is like the interest that like you get. or you owe if it's credit card. So what compound interest does is it's a certain amount of times a year. It's going to take the interest that you've accrued, and it's going to add it to the original like starting amount. So now you're earning interest on top of the interest that you already earned. So basically it just grows really fast, okay? So after that, we're going to go back to this formula and just do exponential decay, which is where you're decreasing by percent, okay? So first we're just going to like practice finding the growth or decay factor. So your growth factors are going to be bigger than 1. Your decay factors are going to be less than 1. So 1 is going to represent 100%. So if it's an increase by 6%, you're going to convert that to a decimal. And since it's an increase, you're going to do 1 plus. So 1 plus 0.06. So that's going to be 1.06. Representing like 106%. The original 100% plus 6% more. So for B, a decrease by 14% is going to be 1 minus 0.14, 0.86, or 86% of the original. If you're not sure how to convert a percentage to a decimal, especially if your percentage already has a decimal, all you have to do is divide it by 100, and it'll convert it. Okay? So this one, for C, what would I do on that one? So you get 1.23. So as you can see, all the growth ones are going to be bigger than 1. All the decay ones are going to be less than 1. Okay? And then for the last one, what would I get? So 1 minus 0.09. So you get 0.9. And then you guys do the last two. Okay, so what would A be? Just the answer. Yep, 1.11. And what about B? Yep, 0.98. Okay, any questions on that? Okay, so that value is going to be your B in the formula. So A is still going to be your starting amount, and then B is going to be this, and then your X power. Okay? All right. So an exponential growth one. Since 2005, the amount of money spent at restaurants in the United States has increased about 7% each year. In 2005, about $360 billion was spent at restaurants. Write an exponential model for this situation. Okay, so we're still going to start with the same formula. Y equals A times B to the X power. I like to use parentheses instead of a multiplication dot. Just because you can do either, okay? So A is going to be your starting value, which is going to be what? Like the original value. Starting amount. And then it's growing or decaying from there. That's going to be for the B. Yep, so 360 billion. So we're just going to use 360 and then just know that our answer is going to be in billions. Okay? So we're starting with $360 billion. And then B is going to be your growth or decay factor. And so to find that, first you need to figure out if you're increasing or decreasing. So what's this one? Increasing it. So you know it's growth. So you're going to do 1 plus the 7%, so 0.07 to get 1.07. So then your final formula is going to be Y equals 360 times 1.07 to the X power. So just on site, because you'll have questions like this, If it's asking you, if it gives you a formula and asks if it's growth or decay, you can just look at the B, and if it's bigger than 1, you know it's growth. If it's less than 1, you know it's decay. Okay? All right, so then the follow-up question, how much will we spend in 2015? So we started in 2005. So from 2005 to 2015 is how many years? Yeah. And it says that this is happening every year. So you're just going to use that as your exponent. And then just round. So throw that in the calculator. Okay, do we get an answer? Yeah, so around 708 billion. Good? Okay, go ahead to the next one. We done? Yes? Yeah? Okay. All right. So on this one, what is your, just tell me the formula. So y equals what? 285 times 1.75 to the x. Yep. Okay, and then how many cell phone subscribers were in the small town in 1994? So what are you using for the exponent? I don't know. So it's going from 1985 to 1994. Yeah, so 9. And then what do we get? Y equals what? $4,472? 43,871?
Yeah.
Okay. 43,870. Are we sure about the 1, 2 when you round it? Okay. Okay, cool. All right, are we all good on that, on growth? Okay, so now we're going to pause and go to compound interest because that's still growth, and then we'll go to decay. Okay, so you're going to want to go back to the notes right before this, the page, so that you guys can see the formula, so we don't have to rewrite it. So here, let's go through what each of these stands for, okay? So it's A equals P times 1 plus R over N to the N times T power. Is your guys' like too faded, or is it fine? It's good? Okay. All right, so A is like going to be your answer always. So you're going to start with P. P is going to be the initial amount that you invest, so the principal. It's always going to be 1 plus. The R is going to be the interest rate, but you have to convert it over to decimal form. So if you need to do that, you divide by 100. N is going to be the number of times the interest is compounded per year. It's going to use words like monthly, annually, semi-annually, quarterly, things like that, and you're going to have to figure out how many times a year that is, okay? N is used in the formula twice. And then T is going to be the time in years that the money's sitting in the account, okay? You know that you're using this formula when you see the word compounded. If you don't see the word compounded, you're not using this formula. So that word compounded right there. That's how you know. Okay. So suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest compounded quarterly. What will be the account balance after 18 years? So let's figure out what our P is. P is the amount, the principal. So what's that going to be? Yep, 2,000. That's how much that was deposited. R is going to be the interest rate as a decimal. I know it's already a decimal, but it's a percent. So you're going to have to divide that by 100, 4.5, to get it not to be a percent anymore. Yep, 0.045. And then N is the number of times it's compounded per year. So it says quarterly. So how many times a year is that? Yep, 4. And then T is the time in years that it's in the account. So what's that going to be? 18, yep. Okay, so remember your formulas. A equals P times 1 plus R over N to the N times T power. So let's plug all that in. So it should look like that.
Did I say N times T at the top?
Yeah. Okay, so there's a couple of ways that you can get this answer in your calculator. First thing, if you're going to do it in pieces, the way that it's written out right now, if you try to type that whole thing into your calculator, it depends on the calculator you're using, whether or not it's going to do it correctly or not. Because of that exponent, if you don't have a calculator that raises up to the exponent, then it's probably going to be wrong, okay? So if you're going to do it in pieces, what I would do first is I would figure out what that exponent's going to be. So 4 times 18. So you get 72. Or just do that right away when you set up the problem, okay? From there, the order that you would go in, you'd start inside the parentheses. First, you would divide this fraction, so 0.045 divided by 4, and get that. Then from there, you're going to add the 1, and then total that out. And then what comes next, exponents or multiplication? Exponents. So then you have to raise that to the power of 72 and total that out. And then lastly, you're going to multiply by the 2,000. Get that. And it's money, so you're going to round to the nearest cent. Now, I'm going to show you the option of typing the whole thing into the calculator all at once, but there's something that you have to do to make sure you get the right answer, okay? Let me write this out real quick. So A equals, make sure you round to the nearest cent the right way. Okay, if you would like the option of putting the whole thing straight into the calculator, here's what you're going to have to add in the calculator. You're going to have to add an extra set of parentheses around this fraction and an extra set of parentheses around this exponent to keep those together. So your calculator does it in the right order. So here's what it would look like. You would do 2,000 parentheses 1 plus parentheses 0.045 divided by 4, close that set, and then close the whole set. Exponent button, parentheses, 4 times 18, parentheses. And then you'll get the right answer. Okay? So it's up to you how you want to do it. If you want to do it in chunks or if you want to just add extra parentheses to keep the stuff together that needs to go first. Any questions on that? We just thoroughly did. Yeah, thank you. Okay, so then the got it, bless you, all the got it is doing is having you change what n equals. So you're changing the 4s to be a different number and then reworking it on your calculator. Okay? Do that real quick. Good? Or not yet? Yes? Okay. So on this one, it just says to change it so that it's compounded monthly. So monthly is going to be how many times a year? 12. So you're changing both ends to 12 now. So it should look like this. A equals 2,000, 1 plus 0.045 over 12 to the 12 times 18 power. So if you type that whole thing into your calculator, you should have gotten $4,489.01. Yes? Okay. All right. Any questions on that? Okay, so remember, only use that formula if it says compounded. Yeah.
How did you get
Because just monthly, that would be like 12 times a year.
Okay.
Because it says, suppose that the account in problem 3 pays the interest compounded monthly. So that means you're changing n to be 12 times a year instead of 4 times a year. To the nearest cent. Make sense? Okay. All right, good, move on. All right, last time is decay. So same thing as like the first ones, same formula. All right, the kilopascal is the unit of measurement for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. Write an exponential decay equation that models this situation. So we're still going to use y equals a times b to the x power. Remember, a is our starting amount, so what's that going to be? 100, yep, 101. And then is this increasing or decreasing? It's what? Decreasing, yep. So, yep, so do 11.5 divided by 100 to get the decimal. So you're going to do 1 minus 0.115 and figure out what that equals. Is it 0.885? Okay. Okay, and then put it all together. So y equals 101 times 0.885 to the x power. All right, what is the approximate pressure at an altitude of 3,000 meters? Be really careful here. What's my next one going to be? Huh? So when is this decreasing? Like, what's a chunk? Yes, there's just 3. So see how it says for every 1,000 meter increase? So 3,000 meters is 3 1,000 meter increases. So that's going to happen 3 times, okay? So we're going to do y equals 101 times 0.885 to the 3rd power. And what do we get? 70, yep. 70 kilopascals, right? All right, good. Okay, we'll just do this one together. All right, a business purchases a computer system for $2,000. The tax code allows them to take off a portion of that purchase for each year the computer system is used. If the value of the system is depreciated at a rate of 15% per year, write an exponential decay function that models this situation. So that word depreciate, it means like it's lowering in value, going down, okay? So what's going to be our starting amount? Yep, 2,000. And then it's depreciating at a rate of 15%. So what's my decay factor going to be? You have 0.85. Because you have to do 1 minus the 0.15, right? To the x power. So I'll do like b equals 1 minus 0.15 equals 0.85. As a little note. Okay, and then it says, how much is the computer worth after 4 years? And in the problem, this is happening every year, so what would my exponent be? Yep, 4. So you should get $1,044.01. Hold on, guys. Let's do this last one. All right. The income of a person increased by an average of 0.8% each year between the years 2000 and 2010. The income of the person was $40,599 in 2000. What was the income of the person 6 years after the year 2000? Round your answer to the nearest whole number and enter it in the box below. So for the formula, y equals, what's the starting income? And then is this going up or going down? Going up. So convert that over to a decimal. So do 1 plus, what's the decimal form of that?
Oh, 0.
But you have to divide that by 100 first, because it's percent. So 0.008 equals 1.008. To the x power.
Wait, but if it's increasing, how can we divide
So that's just to convert it from a percent to a decimal is the division. And then we added it to 1. That's for the increase. Okay, and then what's my exponent going to be? 6. As the nearest whole number. So it looks like 4, 2, 5, 8, 7. Yeah. Okay. And then we will stop there.